So this is Algebra 1, Lesson 1, and we're picking up with 1B. We did 1A in the previous video. So they're talking to us about lines. We know that a mathematical straight line it goes forever in both directions, okay? And so we really can't draw that. I'd still be drawing, right? And for a long time. So what we do is we put these arrows on the ends to show that it keeps going in both directions. Now, here, this is a line, okay, because we're showing that it keeps going in both directions. And this over here is a segment because it shows that it has two endpoints. Now, you can also look at the one on the left and say, well, yeah, but there's a segment here. AX is a segment, and XC is a segment, and AC is a segment. Okay, so we can see segments in this line as well. And it talks to you about how to show the line. Like, how do you know which thing they're talking about? So if I wanted you to know that I was talking about this line, I would draw that. I would write AX and draw a line with arrows on the top of it. That's the same as if I said I'm talking about line AC. It's the same line. I could say that's also line XC. All of those are the same. Okay, because they're all saying the line that contains A and X. Well, that's this line. And the line that contains A and C, and that's the same line, right? And the line that contains X and C, same line. Okay. If I wanted to talk about a segment, I might say AX and just put a line like this above it. That shows it's a segment. So you would read this one line AX and you would call this segment AX, and that would tell you, hey, I don't mean the whole line, I just mean this portion. Okay, so over here I would call this segment MC, or I would write it as MC with that line over it without the arrows. Okay, a segment. And it talks about it being in the lesson. If you read it, it talks about the length of it. They will often write MC, meaning the length of MC, and they'll write it like this with the bar over it when they're meaning the actual segment. Okay, so maybe MC measures 3, so they would say MC is equal to 3, the measurement of MC. And different geometry books do a little bit different things, but that's how this Saxon book teaches it. Okay, now using that, you can do example 1 and example 2. Example 1 actually goes with 1A, lesson 1A, and example 2 goes with 1B, what we just talked about. So back to our previous video where we're getting common denominators, we see that we are adding and subtracting, and we're adding fractions that do not have like denominators. So we're trying to add things that aren't the same size pieces. Okay, we need to make them all have the same size pieces. So we're going to look at these numbers. I'm going to write these numbers out: 11, 3, and 6. I typically like to start with the biggest number, and I think about its multiples. 3 and 6 will not go into 11. If you know your divisibility rules, these are super helpful here, okay? So that's not going to work. 22. 3 won't go into 22, okay? 6 won't go into 22. Well, what about 33? Well, 3 will go into 33, but 6 won't, right? So let's go some more. What about 44? Nope. 55? No. 66. Yes, I can get a common denominator of 66. My 3 divisibility rule says you add up the digits, and if 3 will go into it, then you know 3 will go into that number, and I can see that 66 is the first one that makes that true. Now, the divisibility rule for 6 says if it's even and if it's divisible by 3, then we know it's divisible by 6. So I know 66 works for these. And you can go back to a previous lesson about divisibility rules if you have forgotten about that. But they're super helpful. So I'm writing all of these with a 66 in the denominator. And then I ask myself, well, what can I do to that 11 to turn it into 66. Well, I've got to multiply by 6. So that means I have to multiply the numerator by 6. So I'm going to go to the second one. I'm going to have to multiply by 11 to get 66. So let's multiply by 11 up here. And what would I need to multiply the 3 by? Well, that would be 22. So I'm going to multiply by 22 up here. Now I've got them all in the same size pieces, and I can add and subtract. So I'm going to start with the left. Order of operations says add and subtract from left to right. Okay, so 60 minus 55 would be 5 66 plus 22 66. So all I did was this step and brought the answer down. Now I can add these together. I've got 5 plus 22, which equals 27 66. And I believe that will simplify. It looks like the numerator and denominator are divisible by 3. And 27 divided by 3 is 9. And 66 divided by 3 is 22. And they don't have any further common factors. So that's my answer, 9 over 22. All right, I'm going to go down to example 1, 2. They give us a picture and they say that segment AC. Okay, so let's think about this. Segment AC. So they're meaning this whole thing, okay? So I'm going to label this segment AC. The whole thing is 10 and 1/4 units. But segment AB, that's just this piece right here, measures 4 3/7 units. And they want us to find BC. They want us to find this missing value. Now, sometimes in math, it helps to make something a little simpler, okay? So let's say I had a simpler problem. Maybe I'll use different letters. D, E, and F. Let's say they told us that DF was 10. We'll get rid of the fractions because that's the part where most people get frustrated, okay? And let's say that DE is 3, okay? If you know the whole thing's 10 and you know that this little piece is 3, could you figure out what this is? Well, we can see that this piece plus this piece has to add up to 10, right? So another way of saying that is 10 minus this piece, the whole thing minus this piece, would have to equal this piece. So this has got to be 10 minus 3, which is equal to 7, right? Well, we can use that same reasoning over here. If they want this piece, BC, then we know that this piece plus BC is going to equal 10 1/4. So we can take the total, 10 1/4, take away the little piece that we know, 4 3/7, and find out what BC is. Okay, so now we're going to need to get a common denominator. I think about 7s and I think about 4s. 7, 14, 21, 28. Ah, there we go, 28, 4, 8, 12, 16, 20, 24, 28. They have a 28 in common. Okay, it's not always going to be the two numbers multiplied by each other. That won't always give you the lowest common denominator, but it will always give you a common denominator. So let's put 28 here. And what would I need to do to this 4 here to make it become 28? Multiply by 7. And what would I need to do to this 7? Multiply by 4. So now I can fill those in. This was a 1 times a 7, which is a 7. And a 3 times a 4, which is a 12. I'm going to bring down the whole numbers. And I have an issue like I had earlier where when I go to subtract this, I'll be fine to do the 10 minus 4, but look what happens when I try to do 7 minus 12. That's not going to work. So I can't do the 10 minus 4 yet. I'm going to need to borrow it. This may sound silly, but I think about this as like you're opening a pack of gum. You may be opening one pack of gum, but it's got 10 or 12 pieces in it, right? So when I borrow 1 from here and go down to 9. I've got 9 packs left. Well, I just opened a pack. How many pieces are in that pack? Well, I could have 1 over 1, 2 over 2, 3 over 3, 4 over 4. I can have whatever I want. But since this number is 28, wouldn't it be really convenient if I said my pack has 28 in it? And I've got 28 over 28. So let's rewrite that. Our whole number will be 9. The 1 we took away is 28 28ths. And then I've got the 7 28ths that I already had. And all of those are together. And then I'm going to take away 4 and 12 28ths. So let's put those together. 28 28ths plus 7 28ths would be 35 28ths. And then we're going to subtract 4 and 12 28ths. When I subtract those, I can subtract those whole numbers. 9 minus 4 is 5. And then I can subtract the numerators. 35 minus 12, which would be 23 over 28. And that won't simplify. So that is the end and our final answer.